Okay, so in this demo, I'm going to use some of the techniques of machine learning to process some of our data sets for the PRD. And specifically, I'm going to use the SoFon real estate rental pricing data to generate this kind of map of rental prices in the city. And the result is quite similar to what we saw with interpolation. And we can think of this as basically a smarter or better interpolation using some of the increased power and parameters of machine learning to derive a better understanding of how the prices are distributed in Shenzhen. Okay, so we're going to produce is basically based on a number of training points. So these crosses, the black crosses, are all the points that we know the real estate rental price for. Based on that, we're going to train a regression model, and we're going to implement that model to predict the price at the centroid of each of these 500 by 500 meter grid squares, and that's going to give us the predicted price based on our model. And here you see the visualization of each square being colored according to that predicted price. Okay, so the first thing I'm going to do is pull up our QGIS map. This is our starting map from the data for this week's demo. And here we have our standard water boundary layer that defines our geography. And I also have our grid. And in this case, I'm actually going to use, for our result, a slightly finer grid. So this is actually 250 by 250 meters grid. We're going to use this to predict on our model in the end. And finally, I have all of our known data points for rents in the city. If we go to the attributes table here, you can see that I've already pre-processed these and only kept the columns that relate to price and latitude and longitude. This is basically the same approach we took last week because we already have all these points located in GIS. We're actually going to use QGIS to export the data we're going to train on. And in this case, we're going to use a supervised learning regression algorithm. And our feature data, our inputs, are going to be the latitude and longitude. So it's a two-dimensional problem. And we're going to use the geography, basically, the 2 dimensions of geography, to predict the price. So if you think of this conceptually, it's the same basic approach as interpolation. We're basically looking at how geography relates to a certain value. But in this case, because machine learning algorithms we're going to use have a lot more parameters, we can fine-tune our model a lot better than we can use with the more deterministic interpolation approach. Okay, so once I have this data, you should know how to get here, or you can use the included data in the demo dataset. I'm going to click on that points layer and use this simple export toolbar that we looked at last week to export that data as a CSV file. Okay, so I'm going to export that as SoFon Shenzhen text file. Click Save. Okay, so it's been exported, and I'm going to have all of my data here. Okay, so this is some of the results. This is included in the data file. These are some of the data sets we're going to generate through this exercise. This is my data set of the features and the target values that I'm going to train my machine learning algorithm on. Okay, so the next thing I'll do is start to set up my Python script to perform the machine learning. As always, I need to specify my working directory. And I'm going to set my working directory equal to the directory where all my data is. So I'm going to copy this path. And like always, add in these backslashes. Okay, the next thing I'm going to do is specify where my training data file is. This is a file I just exported out of QGIS, and it's going to be in my working directory, and the name I'm going to copy and paste from my Explorer window. Okay, so the next thing I have to do is import a few libraries that we'll use for the machine learning. The main library to import is the scikit-learn library. So before we do anything, we have to actually install the library. This is pretty easy to do in Canopy. You just go to the package manager, and you just have to search for scikit. And then it should pull up the scikit-learn version 0.15, and then just click on this to install it. Make sure it's installed into your Canopy. Okay, so once you do that, you can import it into our script, and you can import the whole library, but it's pretty big, so I usually just import the parts of it I actually need. So the syntax here is from this library, you just import certain sections. In this case, the sections we're going to use are the pre-processing sections, and it's going to pre-process our data, get it ready for learning, and then also import the SVM. Okay, SVM is a support vector machines library that has all of the functionalities for that learning algorithm. Okay, and another couple libraries we're going to need is the NumPy library, and we haven't seen the NumPy library yet, but it's basically a really general library for working with numbers and numerical operations in Python. And a lot of libraries such as scikit-learn are actually based on NumPy. They use NumPy as a backend to do their calculations. So whenever we use sklearn, we also need to import NumPy. We're going to import that as a shorthand NP, and this is pretty standard way. And finally, we're going to use the random library, and this is just kind of gives us access to random functions that we can use to randomly split our data sets into training and validation data sets. Okay, and the first thing I'm going to do, so I have reproducible results, is I'm going to set the seed. And the seed, you can set the seed for the random functions, you can set arbitrarily, but if you set this in the beginning of your code, then each time your results will be the same. Even though they'll be random, they're going to be repeatable.